Here's 2018 question 2. It's looking like a particle motion problem. Okay, says so right here too. All right, so they give us velocity. Okay, and they tell us at t equals 0, the position is at -5, so we have a starting value here. Okay, we'll keep that in mind for later. They want us to find acceleration. Okay, so you have v of t. So a of t is really just v prime of t. Okay, and you're going to evaluate that at t equals 3. This is a calculator active problem, so you would just go to math 8, d over dx of, I'm assuming you already programmed your v of t to y1, and you're going to evaluate that at x equals 3. That's a quick plug and chug there. You should get, let me double check the scoring guidelines. You should get negative 2.188, 118, okay? And there you go. Here's part B. Find the position, okay? So position, starting with velocity, to go back to position, we're going to have to integrate. Okay, so we know we have to integrate v of t, all right? So remember, I talked about this in a previous FRQ, I think in 2017. The upper bound is going to be what you want, okay? This is what you want. The bottom is what you're given. Okay, so what time are we interested in? We're interested in t equals 3. Now, what time are we given? T equals 0, okay? But remember, you have to consider where you started. So in this case, at t equals 0, I know I'm at -5 here, okay? Plug and chug right there. You should get about negative 1.760. Okay, and we'll move on to part C. Part C, evaluate the integral of v of t from 0 to 3.5. Okay, so this can be done on a calculator. I'll copy the scoring guidelines here. You should get 2.844. And then they ask you to evaluate this. Here you would type math 9 for the integral from 0 to 3.5. To get the absolute value, you would just go to math, right, and 1 for ABS, and then you should get this, y1 dx. You should be able to get, let's take a look here, 3.737. Okay, interpret the meaning. You guys are really good with this, okay? So remember, this, when you integrate the absolute value of velocity, this is the total distance. Okay, so here they didn't really give us units, so you would just say this is the total distance the particle moves from 0 to 3.5. Okay, here is the displacement of the particle from 0 to 3.5. That's basically it. Okay, here's the last one. Part D, a second particle moves along the x-axis with position x sub 2 of t. Okay, so we're talking about a completely separate particle here. Okay, at what time t are the two particles moving with the same velocity? Okay, so with the same velocity, meaning the velocities are equal. Okay, so x sub 2 of t is position here, so the derivative of x sub 2 of t is going to be 2t minus 1. This right here is our velocity of our second particle. Okay, and we're trying to find out what time do they have the same velocity. So what do? We set those two equal to each other. Okay, so 10 sine of 0.4 t squared all over t squared minus t plus 3. We're going to set that equal to 2t minus 1. Okay, now you can do this by hand, but I don't want you to. Your calculator here, this is already programmed as y1. You could just program this as y2. And you could just graph it and find your intersection. See where they graph, okay? Go to second, trace 5, enter, and guess, okay? You should get about 1.571, which is pretty much the time where the two particles will share the same velocity there, okay? So remember, same velocity just means that the velocities are equal. That's it.